Alright, so for this section, we're going to be looking at linear systems of equations. Now this is just going to be a review. So in the next section, or in the next set of assignments you're working on, you'll end up working with linear and quadratics. But I want to refresh your memories as how to work with linear first. So there's two different forms to do here. You've got substitution and you've got elimination. Now the first one we're going to look at here is substitution. You're going to use the same basic idea when you get to the next section as well. But with substitution, I've set up 3 steps for you to work on. So step 1 is solve one of the equations for one of the variables. Step 2 is plug that solved equation into the second equation and solve it. And step 3 is plug that known value into any equation and then solve for the second value. So those 3 steps are going to allow you to figure out what one of the values equals and then use substitution to figure out what that second one is. Alright, so that first step there says solve one equation for one of the variables. Now one equation for one of the variables says basically look at those 2 equations you have. You have 3x plus 2y equals 1 and negative 2x plus y equals 4. And you want to get one of those variables by itself. Now it does not matter which one you choose, but there are intelligent ways to go about these. If you choose that x in the first equation, you're going to end up having to move the 2y over and then divide by 3. And when you divide by 3, you will end up with some fractions because you'll have that 1 divided by 3 and then you'll have the negative 2 divided by 3. And you want to avoid fractions if possible. So the smart way to go about these is to choose a variable that has a coefficient of 1 like this one. There's not a number in front of it. So we're going to solve and get that y by itself. So add the 2x to both sides and you end up with y equals 2x plus 4. So that's step number 1. Step number 2 says plug the solved equation into the second equation and solve it. So we're taking this new part here and we're going to substitute it into my first equation because that was not the equation I used, and it goes where the y is because it is equal to the y from that first equation. Okay, so I take that and I substitute it in. So what you end up getting is 3x plus 2y. Now our new y is 2x plus 4 equals 1. Now what I want you guys to notice is how many variables are left in my equation, and I only have an x left. Okay? If I would have substituted it into the x in the last equation, which is incorrect, you would have ended up with an x and a y, which basically tells you you did something incorrect. So now we're going to solve this. So we distribute. So you've got 3x plus 4x plus 8 equals 1. Combine your like terms. So I've got 7x plus 8 equals 1. And now solve an equation. So subtract 8. That cancels. You've got 7x equals a negative 7. Divide by 7. And our first solution there is x equals negative 1. Now, we've got to figure out what y is when x is negative 1. So I'm going to take this and I'm going to substitute it. And this is step 3. And I can substitute it anywhere. But right here is going to be the easiest place to go. So I've got y equals 2 times x. Well, we know that x is negative 1 plus 4. Okay, so continuing solving this, you've got 2 times negative 1, which is negative 2, plus 4 equals 2. So y equals 2, and there you are. So this is your set of answers where x is negative 1, y is 2. And it actually represents a point. It's the point negative 1, 2, x, y. And that's the point where these 2 equations, if I were to graph them, intersect each other. Alright, so I want you guys to pause this video, take a second, work through that example, and then come back and see how you did. Okay, so hopefully you guys had some time to pause the video, give that a try. So looking at this again, we're going to solve for one equation in one of the variables. Okay, and if you notice, this x is the easiest place to go. It does not have a number in front of it. So we're going to subtract 5y and end up with x equals negative 5y minus 9. Now this new part gets substituted into the x because x is what I solved for. So I've got 4 times negative 5y minus 9 plus 3y equals a negative 2. And hopefully you're following this logic. So we solve for the x, we substitute it into the x. And now you solve. So when we solve this, we distribute. So multiply there. That gives you a negative 20y minus 36 plus 3y equals a negative 2. Okay, go through and combine like terms. So negative 20y and 3y is negative 17y. I'm going to add 36 to both sides. Now be careful with your signs here. Negative 2 plus 36 is 34. Divide by that negative 17. And we end up with y equaling negative 2. So there's your first solution. Now for our second solution, we take that and substitute it in. Okay, so I get x equals negative 5 times negative 2 minus 9. So x equals 10 minus 9. X equals 1. And there you go. So again, those are your two solutions. Now that's substitution. Now the other way to go about this is using what's called elimination. Now elimination, if you get good at this, tends to be the fastest and easier way to solve this. And hopefully you guys remember some of this from Secondary Math 1. But here's your steps. So you use multiplication to get opposite values for variables. Now when I say opposites, I mean numbers that are the exact same number and that have the different signs. So think positive 2 and negative 2. Negative 12 and positive 12. Okay? And so we want to find those things with the variables. Second step, you're going to add those two equations together. And when you add opposites, they cancel out. And that's the whole point. And then step 3 is plug the known value into the equation and solve for the second value. So that's a little bit of substitution there. All right, so for this first example here, you've got a negative 6x plus 14y equals a negative 20. 6x minus 8y equals 8. Now if you notice this, first step says use multiplication to get opposite values. Well, in this one, we already have opposite values. You have a negative 6x and a positive 6x, so there's not really anything that needs to happen. So we're going to add those together. Now, when you add like terms. So negative 6x plus 6x, that becomes a 0. They cancel out. 14y plus a negative 8y is 6y. And negative 20 plus 8 is negative 12. And then you solve for the y, divide by the 6, and y equals negative 2. Now, if you remember from up above, eliminate or substitution took us a little while to find that first solution. For elimination, we've already found it. Now you take this negative 2 and you substitute it back in, and it doesn't matter where you substitute it. You can substitute it right there for y, or you can substitute it here for y. Either equation works. So I'll work with the second equation. So I've got 6x minus 8 times negative 2 equals 8, and from here it's solving the equation. So 6x, negative 8, negative 2 is a positive 16 equals 8. Subtract your 16. Okay, so those cancel. You got 6x equals a negative 8. Divide by 6. And in this course, you need to reduce. So negative 8 over 6. 2 goes into both of those. So that's a negative 4/3. And there's your x. There's your y. And again, remember, this can be rewritten as a point because it is a point where those two lines intersect. And there's your final answer. Okay, last one. We're going to do this one together because it's a little bit different. But what you got to notice here is I've got 3x minus 6y equals 9, and negative 4x plus 7y equals a negative 16. Now, for this problem, there's not a real easy way to make one of those opposites because 3x and negative 4x, they're not opposites. Okay, one is positive, one is negative, but they're not the same values. 6y or negative 6y and a positive 7y, same thing. They are opposite signs, but they are not opposite values. So what I've got to do is I've got to figure out what number I can turn them both into. Now if you think about the x's, you're looking for the least common multiple of 3 and negative 4, which would be 12. Okay, 4, 6, and 7, least common multiple there. And you're going to end up with 42. So it doesn't matter which you choose. The key to this is whatever variable you choose to work with, you get both of those to be the same. So we're going to say the x's and turn them into 12. So for the top equation, to turn my 3x into 12, I'm going to multiply by 4. And for my bottom equation, to turn that into a negative 12, I'm going to multiply it by 3. So I take everything in my top equation and multiply by 4. So that gives me 12x minus 24y equals 36. My bottom equation, multiply that by 3, I get a negative 12x plus 21y. And 16 times 3 is 48. But remember to watch your signs, and you get a negative 48. And so now, if you notice, we do have opposites, 12 and negative 12, and then I add them together. This is now step 2. So when you add those together, your x's cancel. Negative 24y plus 21y is a negative 3y. 36 plus a negative 48 is negative 12. Divide by that negative 3, and you get y equals 4. There's your first solution. And then just like last time, you're going to substitute it in. I'm going to take and substitute it into the top equation this time. So it goes right there. So you've got 3x minus 6 times your y, which remember is 4, equals 9. So 3x minus 24 equals 9. Add your 24. So 3x equals 33. Divide by 3. And x equals 11. And there's your solution. And once again, you can write that as a point, 11, 4. All right, so that is substitution, elimination, solving systems. Hopefully you remember some of that from previous courses. If you have questions, please contact me and let me know.